Good morning. In this session, we evaluate gas tests. Now, gases have different properties, and whenever we evaluate gases, we look at their specific colors, their density in respect to air, their ability to dissolve in water, their pH characteristics, which test whether they are acidic or basic or neutral. And as we do this, our aim is to distinguish one gas with another. For example, both oxygen and hydrogen are colorless, they are odorless, they are less dense than air, they are insoluble in water, and they are neutral. How then do we distinguish between oxygen and hydrogen? To be able to do that, there are some select chemical tests which are conducted in the laboratory, and these include the following. To test for oxygen gas, we normally use a glowing splint. A glowing splint is simply a burning wooden strip which has been extinguished and appears red. So when you bring that glowing splint into contact with oxygen directly, it reignites or relights, and the rekindling process ensures that we confirm the presence of oxygen gas. Secondly, hydrogen gas is tested with a burning splint, in the sense that when the burning splint meets hydrogen gas, it yields a pop sound. Remember that hydrogen gas burns with a blue flame in a vacuum. However, in open air, it burns with a colorless flame and yields a pop sound because of the presence of oxygen, which it reacts with explosively. Next, we have carbon dioxide. Carbon dioxide is normally tested by lime water, and lime water in this case is calcium hydroxide. What we see when we pass carbon dioxide into lime water is that it turns milky or cloudy, and the cloudiness or milkiness disappears after a while with continued passage of the gas through the precipitate formed. In this case, when CO2 meets lime water, it forms calcium carbonate, and when you pass excess of it in the presence of water, it forms the neutral and clear calcium hydrogen carbonate. In that case, therefore, we find that the property of carbon dioxide is also used in the testing for carbon 2 oxide or carbon monoxide. In this case, the carbon monoxide will be subjected to combustion to oxidize it into carbon dioxide, and then the principal test of lime water is used, and it gives us the same principled observational results. Next, we have chlorine. Chlorine is tested by most blue or red litmus paper. In both cases, it bleaches them. In other words, it turns them white or removes their color entirely. Now, chlorine happens to be acidic, so when it meets blue litmus paper, it will turn it red and then white. When, however, it meets red litmus paper, it will remain red for a while, but then it will be bleached into white. Therefore, chlorine is tested by moist litmus paper where it bleaches it. Next, we have sulfur dioxide. Sulfur dioxide is deficient of oxygen simply because the ultimate oxide of sulfur is sulfur trioxide. And in that respect, therefore, we find that the sulfur trioxide is still oxygen deficient because the final precipitate should be a sulfate. In this respect, that it is a reducing agent, we use any reducing agent such as potassium manganate 7 where it decolorizes. In the case that we use potassium dichromate, the color will change from orange to yellow, signifying the decolorization. Therefore, sulfur dioxide is tested by the oxidizing agent where it decolorizes them. Next, we have hydrogen sulfide. Hydrogen sulfide is a gas with a rotten egg smell. This is unique, and therefore the smell is characteristically used as a means of identifying it. However, precaution is to be taken because it is toxic in its respect. Next, we have the nitrogen 1 oxide or dinitrogen oxide, represented as N2O. The dinitrogen oxide has a unique property that it behaves as oxygen by relighting a glowing splint, and it has a unique smell which is sweet. Therefore, the two properties that it has a unique sweet smell and it relights a glowing splint distinguishes it from oxygen and also from other sweet smelling substances such as ethane. Next, we have nitrogen dioxide. Nitrogen dioxide is a pungent gas and it's brown in color. In this respect, we are able to identify nitrogen dioxide by its unique brown color simply because another pungent gas is ammonia. Ammonia, on the other hand, if you allow me, is represented as NH3. Now, ammonia is basic and it is pungent smelling. It is also colorless. So since the nitrogen dioxide has been said to be pungent and ammonia is characteristically pungent, we can differentiate between the two because the nitrogen dioxide is acidic. When it dissolves into water, it forms to acidic solution, namely nitric 5 acid and nitric 3 acid. And when ammonia gas dissolves in water, it forms an alkali in the form of ammonium hydroxide. And this solution is basic in the sense that when you put litmus into it, it will turn the red litmus into blue. Another test for ammonia gas is that of treating it with a HCl. When ammonia gas meets HCl gas, it forms white fumes. Again, when ammonia gas meets HCl solution, it forms a colorless solution. Now, principally, we do the fountain test experiment whereby ammonia is fitted inside a round bottom conical flask, which is inverted over a trough of indicator solution. And this indicator solution has a delivery tube entering the flask and a clip. So when you open the clip, the indicator solution will mix with ammonia, forming a partial vacuum inside the round bottom conical flask. And when you reopen the clip a second time, the indicator solution will be sprinkled inside the round bottom flask as a fountain. Therefore, we can also confirm the presence of ammonia by the fountain test experiment simply because it is highly soluble in water. In summary, therefore, we have said that the different tests for gases have been chosen in respect to confirmed chemical tests in the laboratory, in the sense that most gases have identical physical properties. And we began by saying that the properties of a gas are normally evaluated in terms of their color, their odor or their smell, their solubility in water, their density in respect to air, their pH, whether they are acidic, basic, or neutral. Thank you very much. That has been a description of the gas tests.